Understanding temperature-controlled versus temperature-corrected refractometers. Rudolph makes the J47 and the J57. Both look similar. Both have similar specifications. The J57 is 30% more expensive. Why? Let's look at this in a brief experiment. What we have here are two nearly identical-looking refractometers, the J47 and the J57. These two instruments have very similar specifications, and they look almost identical. The only way to quickly tell them apart is the J57 has cooling fins, and the J47 does not. What's the difference in actual operation, though? The J47 is temperature-corrected, while a J57 is fully temperature-controlled. These instruments have both been on for a while, and what you'll notice is sitting in a room at ambient temperature, the J47 instrument will read approximately 22 to 23 degrees Celsius. The J57, being temperature-controlled, will hold steady at exactly 20 degrees C. Why does it matter in a real-world situation? If you're working in a factory environment where most of your samples are primarily sugar and water, temperature correction will work quite well. As an example, we will measure something simple like sweet iced tea. You'll see it will read about the same on both instruments. However, let's imagine now that our factory is ISO certified. In a situation like this, all instruments would need to be regularly calibrated back to a traceable standard. What I have here is a calibration standard traceable to NIST. While different countries will each have different authorities to answer to, using a traceable standard will always be a component of remaining in compliance. In addition, the calibration standard will not be sugar and water-based, as these are not stable over time. In this case, the standard we will use should measure very close to 9.94 bricks. Thus, if the refractometer measures this correctly, it proves the refractometer is properly calibrated and within specifications. If we place the calibration standard on both refractometers, they should, in theory, measure the exact same results. What we find is the temperature-controlled refractometer measures the calibration standard almost perfectly. The temperature-corrected refractometer, however, cannot measure the calibration standard since temperature correction will not work on a sample or standard that is not primarily sugar and water. We've just seen exactly why even a refractometer that measures primarily sugar and water-based samples will still need to be temperature-controlled. The issue becomes traceability. Temperature correction is acceptable and accurate for certain samples. Those samples that are primarily sugar and water will measure well with temperature correction only, even when the sample temperature is far from the desired measurement temperature. Samples, including calibration standards that are not sugar and water-based, must be measured using accurate temperature control. Production facilities that require the refractometer be calibrated to a NIST traceable standard must be temperature controlled. Why? NIST traceable standards are not sugar and water-based. For more advice about selecting the correct refractometer for your application, please contact us at Rudolph Research Analytical.